ストリア本社から撮影させていただいております。Mr.HEAD、ヘッド博士の方に、ヘッドの歴史を今日は我々にレクチャーしていただこうという時間になっております。
Hello, my name is Ralph. I'm leading the department for research and development here at HET.
So I'm Harry. I'm also part of the same department as Ralph.
So now Harry and you want to not go back to the future with you, but it's back to the past. And yeah, I mentioned, I want to show you something, or we want to show you something more about the past, really mid-80s. And yeah, we have kind of different equipment here. This piece, where you might say, what the hell is this? Then we got something like this. This is another riddle. What is this for? And we got a razor blade. Well, and all this were tools before there was computer-aided design. Technical engineers, the construction engineers, had to do all the technical drawings by hand. And this was the device they used. And this is a technical drawing board. So at that time you used ink pens and you basically made the whole drawing by hand. So thereby you could change here the angle and you had your ink pen and you then had to do everything with ink. And if you made a mistake, then you took the razor blade and you scratched away the ink.
So this was your job?
This was in the old days. So when I studied mechanical engineering, like beginning of the 90s, I still did all my drawings this way. For me, it's interesting because if you look at old records, like for example this one, I think it's like 1984 something. And if you look at this record and the geometry, you might think, oh, boring, because if you look here, you have no special intersections. All the cross sections look like you, but at that time, as said, all the technical drawings had to be done by hand. And as an engineer, you had to calculate all the coordinate points, because this is, where what's important, what defines the geometry. And back in the days, there was no real good pocket calculator. And this was, so to say, a pocket calculator of the past. Don't ask me how it works. It's too long ago. But there was a huge manual, and this means, being the construction engineers, using this, you had to calculate each point. And of course, if you then think about the work, it's difficult to make really complex geometries. Yeah, Harry has some old drawings from the past.
You need a lot of points here describing the frame. So, and all these points you find here in the table with coordinates. And the engineer makes the drawing, then he takes this plan, going to the mold maker, and then the mold maker putting all these points, putting it in his machine, and then making a mold like that out of it. So this was a kind of, to transfer information from a technical department to a mold maker.
So this is an aluminum mold, and yeah, as Harry said, the mold maker, to define how to mill this mold, he needed all the coordinates. And so if you calculate these, don't make any mistake, otherwise it looks weird. And of course, nowadays CAD is much better.
The biggest difference was that this is only a 2D world. That means you have a look from one side on the Racket, and then you have a look from the other side, and then you're getting at this letters here. You're getting cross sections.
You can't get 3D like nowadays.
And there was no 3D.
I mean, here you see a bit the difference. This is the Racket I showed before, and if you look at the cross section, it's like very simple. And this was a Racket that then was introduced, I think, 1990, 1991.
This is around this Racket.
Genesis 660. And you already see here, how the beam varies, so you have more freedom.
This is a special bumper.
Yeah.
Yes,
from the Prestige. So we also had a patent of this, and this can move. And so we have, and this was really to find out how it works. It was a process of 1.5 years of engineering. And then you think, this part has this size. So you see this is more or less the real size here on the drawing.
Yeah.
But this cross section here, like that here.
10 by 1.
So this is 10 by 1. So you have also here the coordinates of this cross section here. You have also thinking about we're talking about millimeters.
Yeah.
There is a change everywhere in the cross section, and you have to write it down and transfer this to the mold maker.
And I mentioned before the razor blade, if we take it a bit away, you see here all the things that were scratched away. You know, a lot of things were scratched away, so the drawing was kind of fine-tuned, revised. Yeah, that was a lot of work.
Yeah, lots of work.
So Manfred, what I heard, kind of his nickname is kind of father of prestige. So, it came out in 1986, 87, and he was kind of, responsible for the development, layups, and also, of course, the cap system. And maybe Manfred at that time, all the drawings were done there.
Oh, the thing,
Yes.
yeah.
You saw yesterday the drawing?
Yeah.
We had no computer at the time. All the drawings were done with such a device.
Manfred now since 47 years with HET.
Yeah.
And so if we talk about history, he's kind of the history person. Only a few, because back in our archive up there we have numerous old prototypes, but we have 2 special ones.
こんなでかいのあったんだ。
How many
Inside.
inside?
Oh, I don't know. Very big.
Very
Very big.
big.
I think 900,000.
5、6、7、8、9、10、
Okay.
11、12。
If you want, you can string it later on.
22本で、縦22ですね。
22。
1、2、3、4、5、6、7、8、9、10、11、12、13、17、18、19、20、21、23。
22、23パターン。
22, 23.
22, 23. That's a really
Not enough ones.
a lot of strings. And talking about strings, we have another prototype, and this is, I think, also dating back to the late 80s. And of course, it's a prestige. And you see at that time, people already, the engineers at that time thought about what can we do, with the strings. In the end, there was no real benefit. That's why it was not used. But it's interesting, to really have a look. Yeah, we have many more Rackets prototypes like this. And I think this really also defines a company if we talk about 75 years.
When you're trying to make it Racket, what was your goal? Like to make it more flexible or more power or more less vibration?
Very good question. And basically, if you talk about playability and performance of a Racket, you have different kind of factors how you can influence it. The first is the geometry. The second is the material. You define stiffness together with geometry. The third is the mass distribution. And the fourth is the string pattern, also including grommets. If we go back to geometry, it can be the top view, how the Racket looks from front, and it can be the cross sections. Is it a box beam or is it a different beam? Is it variable beam? All this different. So these are general the factors how you can influence the performance of a Racket. Now, if we look back at the history of Rackets, there were always some trends. Some years ago it was like the stiffer the better. Then it was like the softer the better. Honestly, I think it's not either or, because it's not only the question how soft or stiffer is a Racket, but where does it flex, at what area. And also it's a matter of taste. And it's similar if you talk about dampening. What vibrations do you want to dampen and what vibrations are important? Because if you hit the ball, you also want to feel, was it good contact or a bad contact? So you need feedback from the Racket. So you need some vibrations. And then also there you have different players and you have different tastes. Some like a more kind of dampened Racket, some like a more direct feedback Racket. And that's also a reason why we have different silos.
that your goal is every different.
Every different player.
Yeah.
Of course,
For
in general, we try to make them a lot of power.
Yeah.
We try to have a lot of control. But you cannot make. There's not the best racket in the world because we all are different. Not only about taste, but some, they play, let's say, more with a maybe straight arm. Others play more like this. Some play more with topspin. Others play more flat. Some attack the net. Others play from the baseline. And I think that's, on the one side, of course, this diversity of players makes it complex for product development. But on the other side, I think it's a huge kind of really benefit and joy of the game of tennis that it's so diverse and so different.
If you see, for us it's more easy because we have our 5 silos and we have to fit the right performance to the right silo. But yet, when you're thinking about the diversity of all the players, then think about the design, the color. So there are also players, maybe they like this performance, but they say, I don't like a yellow racket. I want to play with a yellow racket. So they buy more or less a racket from another silo that not perfect fits to his playability.
Yeah.
So
I mean,
this is the bigger challenge, I would say.
If I think back about, when I was playtesting Prestige Pro 600 in 1993, did I really play better with this racket? I don't know. Maybe I was playing okay, but I was very happy on the court because I was using a racket that even Isilic was playing. So, in the end, we want to make tennis players happy when they hit the court and when they play tennis.
How much effort people put in to make one racket, and so many people involved, like designer or...
It's difficult.
Yes.
It's
So
difficult.
players should be breaking their racket.
Yeah, exactly. Very good point.
テニスプレーヤーはラケット持ったらダメなんですよ。
投げたことないんですか？
ないです。これから投げますね。
Did you sometimes throw rackets? No?
I never broke my racket. I never.
Nice.
Never break my racket. And you?
Same.
Very good.